Hello, my fourth grade mathematicians. This is Ms. Foster with Math in Focus, Chapter 4, Lesson 1, Adding Fractions. In this lesson, you're going to find problems like the one we have here. Lisa ate 1/3 of a pizza, and in the picture, a little hard to see, but that's how much of the pizza she ate. Katie ate 1/6 of the pizza. Here's Katie's sixth. What fraction of the pizza did they eat all together? So here's my problem over here. And the problem with this problem is that I can't add things that aren't the same size. In math, when we're adding things, they have to be the same kinds of things. We don't have a mathematical way to add thirds and sixths. We need to make all the pieces the same size. So we will be using equivalent fractions with common denominators. And that means we've got to look at all of the numbers in this problem and find a relationship. Is one number a multiple of the other? Do some of the numbers share a common factor other than 1? And the answer is yes. 3 times 2 equals 6. So I'm going to go ahead and use 6 as my common denominator. You'll notice I'm rewriting the problem. This is how we want you to do all of your problems, and this will be true in middle school also. We want you to write down every step there. Hopefully yours will be neater than mine because I'm doing this with a mouse. Now the next piece of good news for you is that once this fraction right here is already done, we don't have to do anything to it. It's already a 6th. So we'll just move that over. But my thirds here are having a hard time. I have to use my equivalent fraction skills to change 1/3 into 6ths. And I'm going to do that by multiplying it times 1, except not 1 like this, 1 represented as 2 halves. And I think we can agree that if we have a chocolate bar with 2 parts to it, and I get both of them, then you will be crabby and I will have a whole chocolate bar. Yay! So 2 halves is equal to 1. If I multiply 1/3 times 2 halves, I'm not changing the amount of pizza, I'm just changing the size of the pieces. So 1 times 2 is 2, and 3 times 2 is 6. And aha, I have 6. Now when we multiply in fractions, we're not multiplying the amount. Lisa still ate 1/6 of the or 1/3 of the pizza, but now, when I multiply the pieces right there, we can see that her pieces are the same as Katie's. And now I can add them and find out that 2/6 plus 1/6 is 3/6. But my very good friend over here is reminding us now that we need to remember to write our answers in the simplest forms. Every teacher you ever have from 4th grade on will want you to do this. We love it. So we've got to take 3/6 now and figure out how we could make it simpler. When we simplify a fraction, we're doing magic. This is the one time that I think we do magic in math. What we're literally going to do is erase the cuts. You can't uncut something in real life, but you can in math. And we're going to do it the same way that we made the pieces smaller. We're going to make them bigger by dividing this time. And so we're going to divide this by 1, not 1 like this, or like 2 halves. We're going to divide 1 represented by 3/3 because 3 is a factor of both 3 and 6. So I'm not changing the amount of pizza, I'm just literally erasing cuts. So 3 divided by 3 is 1, and 6 divided by 3 is 2. Now when I really think about it, I realize 3/6 is equal to 1/2 because 3 is half of 6. So you could think about it that way also. And if I come over here and see how I've uncut the pizza, you can see that they ate 1/2 of the pizza. Let's look at some more problems. Now for this problem, we're doing 1/4 represented by red in this picture and by yellow in my fraction bars, and we're adding it to 3/8. Once again, there's no mathematical way for me to do this. I have to get somehow these pieces to be the same size. So I look again at the relationship between all of these. You might think, well, what if I did 4ths? Well, that's a good idea, except check it out. 4 is not a factor of 3, so we can't use it. Instead, I'm going to go with the common denominator of 8 because 4 times 2 is 8. So let me get that here. And then even more good news, this fraction is already done for you. You don't have to find an equivalent fraction in eighths. But 1/4 I'm going to have to work with. So as we did on the last problem, I'm going to multiply it by 1 represented by 2 halves. And when I do that, I find that 1 times 2 in the numerator is 2 pieces, and 4 times 2 equals 8. Now, of course, if you have your fraction manipulatives out with you, you can see right here that 1/4 is equal to 2/8. And so instead of doing 1/4 plus 3/8, I'm going to do 2/8 plus 3/8. Where's my pen? And I can do that right here. And now it's possible for me to add 2/8 plus 3/8 and find out I have 5/8. Are you remembering our friend from the last page? She says we should always write our answers in simplest form. So how can I know if this is in the simplest form? I think again about common multiples and common factors. The only common factor that 5 and 8 share is 1, and that means this is the simplest form. Now, I do love using my fraction models, but I also love bar models. We can do that here as well. So here's another problem, 1/3 plus 2/9. And the problem with this is that even though I made some in the Smartboard document, you do not have ninths on your fraction bars. These things don't exist. So that means you might want to try something else, like drawing this bar model. So here's a bar model, and we want to first of all divide that model into thirds, and we can see that it's 1/3, 2/3, 3/3. But then we've got some ninths here. So if I multiply 3 times 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, we get ninths. And that's the relationship I'm going to use mathematically here. I'm going to use the common denominator of 9. And of course, with my 2/9, I don't have to do anything. I just bring it over. But now I'm going to multiply 1/3 times 1 again, except that 1 will be expressed as 3/3. And we can see that 1 times 3 equals 3. And here they are, 1, 2, 3. 3 times 3 equals 9. Can I add 3/9 plus 2/9? Absolutely I can. And I get 5/9. But I've got to think, is this its simplest form? Do 5 and 9 share any common factors? The answer is no. So there's my simplest form. We've added fractions using models. Let's try it in its most abstract form using only digits. Here they would like us to add 2/5 plus 3/10. Fifths are not the same as tenths, but 5 times 2 equals 10, so I'm going to use 10 as my common denominator. The fraction 3/10 already has tenths, so I'm just moving it right over here. But I've got to use equivalent fraction skills to make 2/5 into a number of tenths. Well, 5 times 2 equals 10. So I'm going to go ahead and multiply 2/5 by a form of 1, 2 halves. 5 times 2 is 10. 2 times 2 is 4. And so now I can add them. 4/10 plus 3/10 is 7/10. Because 7 is prime, I know that 7/10 is in its simplest form. How about adding 3 fractions together? 5/12 plus 1/3 plus 1/12. Well, 3 times 4 equals 12, and 5/12 and 1/12 are already 12s, so I'm going to use 12 as my common denominator. Because the fraction 5/12 and 1/12 are already presented in 12s, I just copied those down. But I've got to use equivalent fractions with 1/3 to chop that up into 12. I'm going to multiply the number of pieces. 3 times 4 equals 12. So I'm choosing to multiply 1/3 by 1 in the form of 4/4. 1 times 4 is 4. 5 plus 4 is 9, and 4 plus 1 is 10. So I got to 10/12, but do you notice how they made another space here? I think they have that there because 10/12 is not in its simplest form. 10 and 12 are both even, so I know they share a factor of 2. I'm going to divide 10/12 by 1 in the form of 2 halves. 10 divided by 2 is 5, and 12 divided by 2 is 6. Because 5 is prime, I know that I have found my simplest form. Friends, thank you for adding fractions with me. I love playing fractions with you. Bye-bye for now.